Imagine you have a container of 30 skeeters. After shaking the container, you add 1 skeeter for every skeeter with its mark side up. How many skeeters would you expect to add at the end of the shake? So after looking at yesterday's activity, you guys had talked about what's the probability of it landing mark side up. And you guys had determined that it would be 50%. So for the first shake, you're starting with 30, and you're adding half of them, which would be 15. So that gives you a total of 45. What would you expect the total population to be after the second shake? So second shake, we have 45, and if we add half to that, that would be 22.5, which gives us a total of 67.5 skeeters. How many skeeters would you expect to add at the end of the third shake? So we have third shake, we have 67.5, and we expect to add half. So what would you expect the total population to be after the third shake? Well, if we take half of 67.5, that would be 33.75, which would give us a total of 101.25 skeeters. So the growth rate for this population, we decided the other day, 50%. So if you had n skeeters before a shake, so we have n, how many skeeters would you expect to have after the shake? So we have n, and we're adding, for each of these, half of n. So at the end of the shake, we would have 1.5 n. So suppose you had 50 skeeters before a shake and the growth rate was 50%. How many skeeters would you have after the shake? So we have 50, the growth rate is 50%, so we're adding half of them. So that means we're adding 25. So how many do we have? 75. We've added 25. Is there a way to shorten your equation to part D? N plus 1.5 n gives us, remember that's one whole, we have 1.5 n, which can also be written as 1.5 n. So if we were to rewrite it as one of our equations, y equals 1.5 to the x. In 1990, the population of Guatemala was approximately 3 million. The expected growth rate is 2.5% per year. Calculate the expected population in each of the 4 years after 1990. So we have 2.5% growth rate. 2.5%. As decimal, 0.025. So we need to calculate expected population in each of the 4 years after 1990. So that means in 1991, we have 3 million times, is it going to be 0.025? Or do we need to find the factor? Because we haven't been multiplying just by the growth rate, we've also been multiplying by the factor. So the factor is going to be 1 plus 0.025, which is 1.025. So 3 million times 1.025 gives us 3,075,000. So then for the next year, we have 3,075,000 times 1.025 gives us 3,151,875. 1993. have 3,151,875. Multiply it by our factor. It gives us 3,230,671. 1994. We have 3,230,671 times our growth rate, 1.025. Gives us 3,311,438. How do you think the expected values for Guatemala's population will compare with the actual values? So we talked a few days ago about if we think the populations will be like our expected, our actual populations will be like our expected. We were looking at the speed of growth and we were looking at the population of the United States. And we had determined that actual values could be lower due to things such as natural disasters, wars, and droughts, etc. Your assignment in the textbook, make sure you show all of your work. You're going to need graph paper to show your data. You're going to graph your data.